Top Secret. Psi Operative Training Mission. Reading Passage. Scientific Method. Mission. Understand the process of the scientific method for use in future missions. Tips. Remember to beam as you read through the passage below. Welcome back, Psi Operative. Even though the Hive managed to kidnap Aki and steal Aki's armor and Nikole's laser, all is not lost. Follow Nikole and Zia's conversation below as they return to the scene of the science fair to learn more about the scientific method. As you read, use the BEAM reading strategy. Details of this strategy are on the BEAM strategy sheet provided to you by your teacher. Refer to this sheet to help you complete the steps of BEAM as you read about Aki's project. Come on, Nikole. You've already remade your laser. We need to get moving if we are going to go rescue your friend in time. Who knows what the Hive is making him do?
We're going to need more than just a laser if we are going to get Aki back. We're toast if we don't secure some kind of protection from incoming laser blasts.
But the Hive took Aki and his armor, so what are we going to do?
Aki had some notes on how he made the armor back at his project stand. We are going to find them and try to recreate it. If he followed the steps of the scientific method, like he was supposed to in the assignment, we should be able to recreate his armor just fine.
What makes this method so special?
Shouldn't you know that, being a Psi operative and all?
I may have skimmed that part of the training. Give me a refresher?
The scientific method is a logical sequence of steps that scientists follow when conducting scientific experiments and investigations. Other scientists are able to follow the exact steps of the process to verify the work done by others. If Aki kept good notes, we will have a record of the steps he took to create his armor.
Let's hope he kept good notes then. His life literally depends on it now.
Don't remind me. Look over there. I think that's where his project stand was.
Can you make any sense of his board? It's all torn up from the Hive.
He's laid out the steps of the scientific method here in this diagram. It is important to note that while we think of the scientific method in steps or phases, scientists often go back and rework their hypothesis and retest their ideas many times after data analysis. Therefore, the process can be repetitive.
The diagram is a flowchart showing the steps of the scientific method in sequence: observation, question, research, hypothesis, experiment, data, and conclusion. An arrow flows from the conclusion back to observation, showing the cyclic nature of the process. Okay, so walk me through this.
First, he made some observations. An observation is anything that is noticed using one of our 5 senses. It is something that we see, hear, touch, smell, or taste. Once scientists have made an observation, they ask a question. These questions may include why something is happening, what would happen if something is changed in a scenario, or how a process or product can be improved.
It looks like Aki wrote his observations here on this board. Metals melt at different rates. Then he asks the question, how can I create body armor that can withstand long laser beam blasts without melting? Is an observation and question enough to plan a whole experiment? Seems too easy.
Once scientists have a question in mind, they do research to learn more about the topic. You need to know what knowledge and facts already exist about the topic you're investigating. Aki's board has information about the properties of metals listed and the definition of melting point. He learned all that through the background research he did before performing this experiment on his prototype armor.
Aki's research. Properties of metals. Shiny, very hard, good conductors of heat, good conductors of electricity. Higher densities. Most are solids at room temperature. Malleable. Ductile. Melting point. the temperature at which a given solid will undergo a phase change to become a liquid. Aki also included several photos of metals with his research. Look here, underneath the research section. There's a box labeled hypothesis. Why do we need a question and a hypothesis?
The initial question is made based on observations and what the scientist is curious about. Once a scientist has researched their question, they will develop a hypothesis.
Makes sense. So, let's look at the theories Aki has come up with.
Not quite. A hypothesis is different from a theory. Science uses the word theory in a way that is different from its everyday use.
I thought a theory was an untested hunch. How is that different?
A scientific theory is an explanation for observations of the natural world that is carefully thought out and has been created and supported by the scientific method, pulling together many facts and hypotheses. It attempts to explain how or why something happens and is very complex. A hypothesis is a testable explanation for what the scientist has observed. It is a starting point for creating an experiment to test their idea. In order for a hypothesis to support the process of science, it must be tested in a controlled experiment. Hypotheses are usually written as if-then statements.
So, Aki's hypothesis might have been something like, if I use metal with a higher melting point, then the armor will withstand more laser blasts. Testable is easy enough to understand, but what do you mean by controlled experiment?
A controlled experiment is a process where one variable is tested at a time with results being measured after each test. Here's an example. When I was making my laser, I got a lot of grease in my hands. I had 4 different soaps, and I wanted to find the best soap to scrub the grease away. If I used all the soaps on my hands at the same time, I wouldn't be able to tell which soap actually worked best.
Well, of course, that would be silly, not to mention wasteful. I would use one soap at a time.
Exactly. You would control how the soap was used. The soap is a variable, a factor that is changed, measured, or kept constant in an experiment.
Wait, wouldn't the amount of grease you removed also be a variable you could measure?
Yeah! Changing the variable you start with can change the outcome of your experiment. Because of this, variables are broken down into 2 types: independent variables and dependent variables. The independent variable is the variable the scientist is changing in the experiment, and the dependent variable is the result that occurs because of the independent variable's change. In my soap example, the soap would be the independent variable, and the amount of grease removed would be the dependent variable.
Independent versus dependent variables. Independent variable is the cause or manipulated variable. Dependent variable is the effect or measured variable. So for Aki's experiment, changing the metal in the armor was his independent variable, and the time it took the metal to melt would have been his dependent variable. But what if he used more than one metal?
That would have been some bad science. One thing I have learned from my project is that it is crucial when doing a controlled experiment that only one variable is tested at a time. Aki would have been sure to only change one metal in his armor and then record how it changed the melting point. The other variables he kept constant throughout his experiment would have been called control variables. This way, he could show, with his data, which change made the most difference in the melting point. We know that changing more than one variable at a time makes it impossible to say which change caused the result you are seeing. If Aki kept good records of the changes he made and the results he saw, we can use that information to recreate his experiment.
Gotcha. Look here. Under the Analyze Data section, the page seems to have been ripped away. Huh. It's a bit ironic that the Analyze section is gone when that's the part we need the most.
That would be funny if Aki wasn't in danger right now and didn't need us to know this information like yesterday. Luckily for us, all experiments create data, which will be the clues we use to retrace Aki's steps. Data is factual information gathered from an experiment. It can include measurements, the sequence of events, and observations. When Aki tested his armor, he collected two types of data here in his project.
Two types of data?
Yes, quantitative data are measurements or data that can be counted or compared with numbers. For Aki's experiment, that would be the temperature of the armor, the time it took to melt, and the weight of the armor. Data is often analyzed and classified to serve as evidence to support or reject an idea.
Quantitative is like quantity, like numbers. Got it.
He would have also collected qualitative data. Qualitative data is descriptive. In this experiment, it would be the order of events as the armor heated up and melted, and what he saw, heard, felt, and touched as he tested his prototype.
Okay, so Aki made observations, did research before testing his armor, created a hypothesis, did an experiment on his prototype armor, and collected and analyzed his data. I see one more blank space on his board. What would have been the last step of his project?
The last step of the scientific method is very important. It's reporting your conclusions. A conclusion is a summary statement of the experimental data. The conclusion can support a hypothesis, but it can also disprove a hypothesis. If a hypothesis is not supported, scientists go back to previous steps of the scientific method and create a new hypothesis based on their data.
And the cycle continues.
Yep. Conclusions are detailed explanations of the experiment and the data collected. They include explanations of the results and possible pathways for further research. The goal of science is not only to test ideas, but to have those tests be reproduced by other scientists. We do this by sharing the details of our results. If Aki wrote a good conclusion, it would tell us what he discovered through his tests.
Then what are we waiting for? We really need to find this missing piece.
Aki's notebook should still be in the lab. I bet we can use it to reproduce his work and rebuild his armor. Let's go!
Make connections. In each box below, write a connection between a text that you just read and either your prior knowledge or something in your life. Reading comprehension questions. Scientific method. 1. What is the relationship between making observations and forming a hypothesis? 2. Why is it important that a scientist only tests one independent variable at a time when performing an experiment? 3. Using the example of hand soap to remove grease from Nikole's hands, list 3 control variables that could be used when testing the effectiveness of hand soap. 4. Label each statement below as true or false based upon the reading. A well-written hypothesis should include the independent and controlled variables of an experiment. Observations about the natural world are made after performing an experiment. Data can be analyzed to prove or disprove a hypothesis. It's okay to test multiple variables at once as long as you keep good records of your data. A conclusion can include reasons why a hypothesis was disproved and ideas to test in the future. Five. What should a scientist do if they find that their data does not support their hypothesis? 6. Number the following descriptions of the scientific method in order from start, 1, to finish, 6. Nikole reviews the measurements and observations collected during her experiment and looks for patterns. Nikole spends time reading information related to the topic she is interested in and finds out what other experiments have been performed related to the topic. Nikole tests her hypothesis, controlling for variables throughout the experiment that she does not want impacting her results. Nikole writes a report that discusses whether or not her data supported her hypothesis and shares it with others. After reading about her topic, Nikole creates an if-then statement that includes the independent variables she is interested in testing and the dependent variables she will be measuring. Nikole notices that using different gases in her laser produces stronger laser beam blasts. She wonders which gas will produce the strongest laser beam burst.